We hear it constantly in software, don't we? This relentless drumbeat of speed and automation,
Mm.
faster, quicker, automate everything. But honestly, for a lot of traditional software processes, that race, it feels like it's hitting a bit of a wall. The real innovation, well, it's probably not just about raw speed anymore. Okay, so let's unpack this a bit. Today we're doing a deep dive into AI-powered CI/CD, really looking at how machine learning is starting to fundamentally change how we build and deploy software, truly optimizing those pipelines in a new way.
Exactly. I mean, traditional CSED, it's built on this very uh, rigid, predictable model, like an assembly line. It sort of assumes every step is the same, every input leads to a perfectly predictable output. But software is just, it's organic, right? It's unpredictable, full of these complex interdependencies, weird edge cases, things that simple rule-based automation just can't really handle well. Machine learning, it transforms that entire equation. It makes the pipeline intelligent.
Right, and this is where the shift gets really interesting for you listening in. Think about those, well, painful realities of the traditional setups. How many times have you or your team maybe spent hours, maybe even days, just debugging some mysterious build failure? Something that turned out to be, I don't know, a subtle timing issue.
Oh, all the time.
Or that frustration of running every single test in a huge suite for just like a tiny one-line CSS change.
Mm.
AI is basically designed to tackle those kinds of deep inefficiencies.
And it's not just theory. We're seeing real concrete impacts. Take Netflix. They're doing something like 4,000 deployments a day. That's huge. So to manage that scale, they trained machine learning models on, I think it was 2 years of historical deployment data. And this system, it assigns a real-time risk score to every new commit, kind of like a green, yellow, or red light.
So it's predicting stability.
Exactly. How confident are we in this change? And the result was pretty remarkable. A 23% drop in failed deployments and 31% faster average build times because the system flags risky changes before they break things.
Okay, that's significant. What about others?
Well, Spotify had a different challenge. Over 50,000 automated tests for their mobile app.
50,000.
Yeah, running them all took like 45 minutes, which, if you're pushing hundreds of commits daily, that just doesn't scale. So they implemented something called test impact analysis. It's not just running fewer tests randomly. It's an AI system that actually learns the relationships, between specific code changes and the tests most likely to be affected by those changes.
So it's targeted testing.
Precisely.
Right.
Surgical. Instead of running all 50,000 for a small tweak, it intelligently picks only the critical few. They got a 67% reduction in test execution time. And crucially, they maintained 99.2% bug detection accuracy. So speed and safety.
That's impressive precision. Google must be doing something interesting too.
Oh, absolutely. Their internal system, TAP, I think it processes something crazy like 4 billion test results a year. It uses multiple AI layers, things like anomaly detection, spotting weird patterns, and predictive scaling, so anticipating resource needs to avoid bottlenecks. Plus, they use failure clustering. The AI groups similar errors, automatically pointing towards root causes.
Okay, failure clustering. That sounds powerful.
It really is. They estimated it saves something like 12,000 hours of developer debugging time in just 1 year. It's like moving towards self-healing infrastructure.
Now, I can imagine some listeners thinking, okay, but isn't a lot of this just marketing hype? You see AI powered everywhere. How do you tell what's genuinely intelligent versus just, clever branding, especially with talk of self-healing systems?
That's a really fair question. And yeah, there's definitely noise out there. But some companies are doing genuinely innovative work. Launchable, for example, they've really focused on that test selection problem we talked about. They're seeing results like 70% reduction in test times with basically zero missed defects. That's solid. And Harness, they focus a lot on deployment intelligence, building risk profiles for releases, doing smart canary analysis.
Canary analysis, the slow rollout monitoring.
Exactly. Using AI to watch those small initial user groups detect issues way before a full rollout. It's smart deployment.
Okay, so the tech is real, but what about actually using it?
Well, that leads to the hard truth about implementation. It raises that important question. Is it easy? And the answer is, frankly, no. Not yet. It can be messy. It can be expensive. You need data. Lots of it. Good quality historical data, often like 6 to 12 months worth, properly collected and cleaned, just to start training a model.
So a significant upfront investment in just data prep.
Definitely. And then you have to deal with initial false positives. The AI might flag a perfectly good build as risky, or maybe suggest skipping a test it shouldn't. Tuning these systems, clouding them, that takes constant attention, especially early on. Plus, the tooling itself is still, well, pretty new. Most platforms are maybe 18 to 24 months old, so you might end up building custom bits yourself.
Okay, so given those hurdles, the data needs, the tuning, the immature tools, let's circle back to the listener. What does this really mean for your day-to-day? Is the payoff worth that upfront pain?
I think what's fascinating is just how big the payoff can be when you get it right. We're seeing systems hit like 84% accuracy in predicting build failures. Imagine preventing all that wasted time in compute. And think about flaky tests. Everyone hates those, right? Tests that randomly pass or fail.
They completely erode trust in the pipeline.
Exactly. AI is helping achieve things like a 92% reduction in flaky test false negatives, meaning the system gets way better at catching those intermittent problems accurately. That builds developer confidence back up, saves hours of frustration. And financially, we see numbers like a 35% decrease in CI/CD infrastructure costs because resources get used so much more efficiently. But maybe most importantly, developers start to trust the system again. That's huge for productivity, for morale.
It really sounds like, while it's not maybe a simple plug-and-play thing for every team right now, the potential competitive advantage is just undeniable. The benefits seem too big to just ignore.
I think that's right.
So pulling all this together then, what's the big takeaway here? It feels like this isn't really about replacing the old CI/CD idea entirely. It's more about fundamentally changing what we expect from it.
Right. Absolutely.
For the latest tech insights, visit em360tech.com.